Good morning, children. In the previous class, you studied what is the meaning of dimensional formula of a physical quantity, and you have written 6 dimensional formulas yesterday. Today, we are going to write some more dimensional formulas. One is heat. You know what is heat? Can you define what is heat? It is a form of energy that produces the sensation of what sensation you are having due to heat, warmth. Right? So it is a form of energy. So heat is an energy. And energy, what is energy? Ability to do work. The work and energy are same. Work done, energy, potential energy, kinetic energy, all these are mechanical energy. All these are various forms of energy. So in dimensional formula for all these energy forms are same. Yesterday you written what is the dimensional formula for work? What was that? Work done. Force multiplied with displacement. Force is mass into acceleration into displacement. Mass is mass itself and acceleration is LT minus 2 multiplied with the displacement, one more L. So that is why it is L square. So ml square T minus 2. This is the dimensional formula for work done and dimensional formula for any energy form, dimensional formula for heat energy also. Now you can say another very simple term that is called density. You know what is the definition of density? In class 9 you studied density is equal to mass upon volume, right? If you divide mass with volume, you are getting density. Mass is mass itself. Density today beginning we studied L3. So your dimensional formula will be mass 1, length 3 and there is no time. So time 0. And another time which you studied in class 9, that is relative density. How you define relative density in class 9? Density of substance. Density, you know what is the symbol used? D. Another symbol is rho. This is the symbol for density. So density of a substance divided by density of water. That is called relative density. What is the formula for density? Mass upon volume. And what is its unit? Can you tell the unit from this? Mass is kilogram. Length is meter. So what is unit of density? Kilogram per meter cube. Is it right? Okay. Now if you divide the density of a substance by density of water, you are getting an answer. What is unit of that answer? Is there any unit? There is no unit. The reason is this one. Density upon density. Both the units cancel each other. So is there any unit for relative density? No unit. No unit means no dimensional formula. No dimension. M0, L0, T0. So this is an example of a physical quantity. Is it a physical quantity? Definitely. But is there any dimension? No. So it is an example of a dimensionless physical quantity. Is it variable or constant? It is variable. For different substance, the relative density is same. So this may be asked as another question. Give an example of a physical quantity which is a variable at the same time dimensionless. Dimensionless variable. Example is relative density. Now see refractive index. This is also based on your class 10. Refractive index is sin I divided by sin R. Right? So both are sine angle. So again dimensions cancel each other. So this is also an example of a dimensionless physical quantity. So this is also an example for dimensionless physical quantity which is a variable. Now see another very important physical quantity that is called universal gravitational constant. This is studied in your class 9. Universal law of gravitation. According to universal law of gravitation by Newton, F is equal to G(m1 m2) divided by distance square. Is it right? Now from this one you can write G. G is equal to Fr square by mass 1 into mass 2. From this you can make the dimensional formula for universal gravitational constant. Let us see. Is equal to force. Force is mass into acceleration. That is called force. R stands for distance. R square means distance square divided by mass 1 kilogram, mass 2 also kilogram. So mass 1 into mass 2 is mass square. Is it right? Mass into mass is called mass square. Now you can see mass cancels. Now there is one mass in the denominator that is going to the numerator. So it will become m minus 1. And acceleration, you know, acceleration, what is the dimension formula? Lt minus 2 into distance square, L square. Now combine all the powers. So your answer will be m minus 1 L3 T minus 2. See, mass minus 1 L power 3 T minus 2. Now, in which group this is coming? Is it a constant? Constant. Is there a dimension? Yes. So it is an example of a physical quantity which is a constant, at the same time it is having dimension. So dimensional constant. What is this one? Dimensionless variable. What is this one? Dimensionless variable.